Okay, so here we are doing number 6, and I'm recording this. This is a problem that we didn't do in C block, so this could help you get one more example. For those of you in D block, what you'll want to do is look at the movie on number 5 and try to do that problem. So we just get a little more practice by having two different recordings with two different problems. Okay, but it's essentially the same problem with some, hopefully a little bit more realistic numbers. But in any case, what we have here is poor Gus is out in the ocean, and he's found himself 2 miles directly east from where he'd like to be. So he needs to go west, and he wants to go directly west, not off at some angle, because that's where the island is he needs to get to. But there's a problem, and the problem is that there is a north moving current that's going to push him too far north. So clearly he's going to have to swim a little bit south to compensate for that, so that he ends up going exactly west. Fortunately for Gus, he can swim 1.5 meters per second, which is more than the current, so he's going to be able to actually do this. And so if he picks the right angle, he can get there nice and smoothly and easily. The problem is when I draw this 1.5, I don't know what direction to draw it. And in fact, that's pretty much going to be the wrong direction, because we know he needs to have a little bit of a south to it. So if I look at this and think about, okay, well, which direction can he swim? He doesn't want to go east because that'll get him away from the island. He clearly wants to go west towards the island, but he needs to go a little bit to cancel the northward current. So he's going to do something, I don't know, something like that, because he needs to go a little bit south to cancel the north of 0.7. And in fact, he wants the components of his 1.5 swimming. Let me get that 1.5 out of the way there, because he's got 1.5 that he's swimming. He's going to want to be going towards the island because he needs to get to the island, but he's also going to have to swim south to cancel the north current. And so he actually wants to exactly cancel that. So this is going to be 0.7 south. And if you've done a lot of right triangle trigonometry, you're like, okay, well, I'm done now. The problem is going to be easy to solve, because if I know 2 parts of a right triangle, I can get the third part using the Pythagorean theorem. So let's do that real quick and see if you guys get the same answer I do. Anybody have an answer yet for that side, or am I going too fast? Nobody wants to speak up when it's live on YouTube, I guess.
Wait, I do have a question.
Yes, please. Good.
Why can't? Because like when I try to do the triangle, I just tried to find the diagonal for making like 2 miles to the left and then point 0.7 meters north. Is that
Right.
like not correct?
No, you're not going to be able to do that. And the reason is what you're doing is you're mixing distances, right? You're mixing distances, excuse me, you're mixing distances with velocities. So this right here where it says, hello, this where it says 2 miles, that's a distance, and you can't have it in the same triangle with velocities. When we do a triangle, everything in the triangle has to be velocities. And so the distance is just, it's off to the side. We're going to worry about it later. Right now we can only work with the velocities. That's a great question. Okay, so
Okay.
right now we just have the velocity, we just have the velocities only, and our goal is to make these velocities the correct direction. And then once we have that, then we'll come back to the 2 miles, I promise. But right now we got to start with this. Okay? Did someone get 1 point? Did someone verify my triangle? Anybody get that? Okay, great. So when I arctan this thing, I'll get the angle that Goose needs to be swimming. And actually, I could arctan it. I could also, I want to show you that I could also arcsine it. And we'll talk about which one's a little, yeah, they'll be slightly different. And we'll say which one's actually a little bit better. And they're almost the same. But because the original given information, since the original given information was the 0.7 and the 1.5, technically it's a little better to use the arcsine here. But it really doesn't matter. I mean, it really doesn't matter. And I certainly would never mark any points off for doing the other one if that's what you decide to do. We've been doing a lot of arctan, so it's likely that we would do arctan. Okay, so notice what we've figured out. We've figured out that he needs to swim 28 degrees, right, south of west, and that he ultimately will not be moving at 1.5. He is not going to be going 1.5. Hello. He's going to be going 1.32, not 1.5. Okay, meters per second. Okay? So that lets us know what direction he should go, the answer being 28 degrees. And so now I'm going to do the unit analysis. And so I'm going to go ahead and do it with unit analysis, and I would encourage you to do it with unit analysis as well. The 1.32 meters per second is going to be a conversion factor for us. We're going to use this as our conversion factor. Notice that's the vector that's actually getting him over to the island. Okay, the 1.5 is not getting him over to the island. Only 1.32 is. So let's do a little unit analysis. So we're going to start with 2 miles. And the first thing we want to do is get into the metric system. So I'm going to say that 1 mile is 1,609 meters, which I happen to know because I coached track and field for a while, and so we had to mark the track, even though it was a mile track, to 1,600 meters. In any case, now we're in meters, and that enables us to use this velocity of 1.32 meters equals 1 second. Okay? So meters on top is going to cancel the meters on the bottom only if I have the 1.32 meters on the bottom and the 1 second on top. Okay? And then finally, I need to go seconds to minutes. So 60 seconds is 1 minute. And let's see how that works out. So people, please check my answer so that I make sure I didn't mess this up. So I'm just dividing, and then I'm dividing again by the 60, and I'm getting about 40 minutes. 2 miles, 16 minutes, 1600 meters.
Yeah, I got 3.63 minutes, but.
Did you use the 1609?
Yeah, me too. Yeah. Like, I got the exact same answer as you got on your calculator.
Okay, sweet. So we can say 41, say?
Yeah.
Okay, so let's just say 41 minutes, and that is how long it will take him to get to the island. So we're done with the questions. So I'm going to stop the video here, and then you guys can ask more questions, but I'll go ahead and stop the video. Unless somebody has a question you think will help everybody else for the video? No? Okay.